Hey everyone, thanks for showing up at Signal, and I'm looking forward to this talk. So, I'm Rob Brazier, Director of Product Management. These days focus primarily on programmable video. The great demo you saw earlier from Luis is one thing I'm really excited about, and we'll be talking about some of those models that you saw represented in Luis's presentation here, and a bunch of other things. I wanted to take some time. I've been thinking about this talk for a while because I've been noticing that the communications apps that are built on Twilio that work best of all take some fundamentally different approaches to calls. But I see a lot of people who are building new Twilio apps for the first time, sort of struggling to find out what's the best way to design a calling experience. So I just kind of wanted to go through a survey of some of the examples that I've seen that work really well for different use cases. But let's start by talking through, what do we mean when we say a call? What can we say about a call's design? What are the constraints of a call? How does it behave? Well, usually when we talk about a call, at Twilio, we talk about calls all the time. We always talk about Alice calling Bob, or Bob calling Alice. What we mean by that is we have this set of properties that are common in calls. Number one, we have a point-to-point connection, usually a two-participant conversation. These are sort of the expectations we have that we've had for years of doing phone calls. A call usually requires some sort of explicit invitation to connect. Someone needs to ring you, or you need to ring them. Calls are marked by an interrupt-driven, very short-lived notification. Your phone rings, and you've got to answer it in a very short amount of time. This is kind of part of the call model. This is just what we get when we think about calling in a traditional PSTN application. The other thing about calls is that there's no history. When one of the participants drops, when one of the parties drops, the call is over. That's it. And calls are, to some degree expensive to set up. This is kind of a nuanced point, but how many people in here have built telephony applications in the past? Not on Twilio, perhaps, with SIP or other things. So few hands are up. If you have some experience in telecom, you'll know that protocols like SIP, which we'll talk about a little bit further on, are they have a lot of state, and there are a lot of issues in setting up SIP calls. So these are some of the constraints of a classic call model. These assumptions about how calls ought to behave have been built into a lot of our infrastructure. We've built a lot on these assumptions. So a good example, like I just mentioned, is SIP. This is a typical SIP call flow diagram. SIP has this idea of an invite, a synchronous notification that has to be sent from one party to another to set up a call. It's built so that it can ring your phone. This is built into the protocol that powers the PSTN, the SIP protocol, and a protocol that many people are still using to this day, including Twilio. We use SIP in many cases where it's appropriate to power voice applications. But it's not just protocols that have built the assumptions of a call model into their very nature. It's the infrastructure too. This is very old phone switch back from the early days of the PSTN. The whole idea of a phone switch, you only need a phone switch if you have a synchronous calling model like we talked about before. Think about it. A switch's job is to switch your phone call from one service to another throughout the life of a call. You only need that if I hang up the phone, my call is over, I can't get back to where I started. Think about the different services that you are switched between when you call a business, for example. You might hear an IVR for a while, then you're switched to a queue, then you're switched to the agent. These are all familiar experiences to us. But if any of you have worked in telecom, even recently, you know that this whole idea of a calling model where you switch between different services is still built into even very successful call center platforms, PBX platforms even today. And of course, we've also built the assumptions of the calling model into the user experiences we create. Again, because calls are synchronous, because they're expensive to set up, we do things like, well, we don't want you to have to call again. We can't give you a good visual when we're using the classic phone call, so you have to wait on hold. We have to play you some music. These are the kinds of things that happen in calling. But a lot of the assumptions, a lot of the context that led to the creation of the traditional calling model has changed. This is obvious to all of us, but sometimes, again, it makes sense to revisit some of these assumptions to think through, well, how could calling be different? So a few of them that I've called out here. When phones were initially developed, you had pretty much a one-to-one mapping between a single person and a single device, or even a single household and a single device. I could give you my phone number, and you knew that phone number was my home phone number. I probably had a different phone number for my office, and when car phones came along, I had a different phone number in my car phone. These were all separate numbers. They mapped directly to an individual device. Obviously, that's over the last 15 years, that's completely changed, and in fact, it's completely flipped. One person now has many devices, and they have one identifier, an email address, or a Facebook ID, or even their SMS number can identify multiple devices. And you might be reaching that person when you send a message to that SMS. You're probably reaching them wherever they are on any of those devices. Same thing. Phones existed in a single geographic location. Phones were designed for a single modality. This is an important point. If any of you are thinking about adding VoIP to your applications, well, the assumptions of the calling model were built for a world where you only ever did voice calls. Another interesting thing that's shifted is that calls were developed in a world where a phone number, like I said, maybe it mapped to a household, maybe it mapped to an office. Well, so when you called that number, you needed to make sure you had the right person on the line. You needed to verify their identity. You needed to say, hey, can I speak to Bob? Now we all carry phones in our pocket. There's a very high likelihood that whoever answers my phone is probably only me. Some of these other points go without saying. Another one that's important for some of the things I'll talk about later is the shift from relatively stable fixed line connectivity to wireless connectivity. This is another one that's obvious to all of us, but we need to think about how it changes the way we develop calling experiences. So we'll get into this a little more. So here are a few of the things that we've observed at Twilio, I've observed personally from working directly with customers. There are kind of 4 lessons I want to take some time to talk about. The first one is that using a hub and spoke model for calls, or you might say a conference or a room, this is a better model for calling today than a point-to-point connection. And even though Twilio supports both a point-to-point connection through, for example, our dial verb, I would encourage all of you, if you're looking at building a Twilio voice application, to look at new primitives like our conference primitive or our conversations primitive that are built to be multi-party from the beginning. And we'll talk about this more in a second. We'll talk about why soon. Next one, we operate often under the assumption that we can only do one call at a time, but is that true? We'll talk about that. We have to think carefully about how users discover calls and how they receive notifications about calls, how they join and leave calls. And finally, last point, and it's particularly resonant given the sync demo we saw earlier today, we need to talk about synchronizing state across endpoints, because in a multi-device world, this becomes more and more important. So let's dig into these. So what do I mean when I say a hub and a spoke model is better than a point-to-point model? Why is the conference a better model for today than this old call model that we're used to? Well, let's go through some of those points I made earlier. If you've got a point-to-point call, any of you who are developers in the room know that you might start with a relatively simple feature set in your application. You build a point-to-point calling experience, but then someone walks over a week after you've shipped it or the day after you've shipped it and says, hey, wait, we need to add another feature. And I think for this feature, we're going to need we need a manager to be able to listen in on the call, to moderate the conversation, for example. That's a common use case in a call center application. Or we want to be able to do what's called a warm transfer. We want to have the agent bring in a tier 3 escalation agent. We want to transfer the call to them. we want to add more people to the call. These are, of course, classic multi-party scenarios. You can't do this with a point-to-point calling model. You have to introduce something else in the middle. Requiring explicit invitation. This is kind of baked into the calling model. But what happens if you want to coordinate calls in a different way? I'll walk through some examples in telemedicine a little bit later. But there are plenty of cases where maybe you don't want to interrupt the user with a synchronous invitation to get them on the phone. Maybe you want to notify them about a call in a more gentle way. Also, what happens when calls drop? We talked about wireless connectivity earlier. The reason we launched the Voice Insights product today is because we know that last mile connectivity isn't so hot. There's still a lot of work to do to get reliable network connections for all of our users. So if the call drops, how do we reestablish the session? A hub model helps us solve this problem. We talked about the problems of interrupt short-lived notifications. What about mobile notifications? What about shifting consumer expectations? I think you could argue one of the reasons messaging is taking over communications is because consumers, we're carrying phones in our pocket. We are often doing something else, and an interrupt like a phone call, like a classic phone call, just doesn't fit with our lives anymore. An asynchronous notification like a push or a chat is just better for us. So shifting consumer expectations maybe should cause us to consider a different model. And with a hub and spoke approach, you can keep notifications separate from your actual call. We talked about the problem of not having any history in a classic call model. But what happens if we need to talk again, if we need to pick up that conversation where we left off? And then, finally, if a call is expensive to set up, if we can move to a less complex or a less expensive model, everyone's going to be happy. So, what I mean when I say hub and spoke is something like this. Rather than the call being the connection between these two participants, and as soon as one of those two participants leaves, the call is over, let's introduce a better call here. And like I mentioned, it's no longer a point-to-point connection. We can cross that one off the list. It no longer requires explicit invitation to join. If you know the name of the hub, you can connect to the hub, whatever that is. So in our conference primitive, we give you the ability to name a conference when you connect to a conference. In our programmable video API, we'll have an upcoming feature where you can name a video room, so that you don't require explicit invitation to join. All you need to know is the name of the room. You can do notifications however you want to. The hub exists whether or not all the parties are connected. And it's not any more expensive to set up. Now, you could argue that, there's some state that we have to manage, but all that state moves to the hub rather than being managed at the endpoints. So it can be a better way to do things. So that's why a hub model is better. But I want to start to unpack a little bit more about what you can do once you've moved to a hub and spoke model. This is one thing that I find most people haven't considered, but sometimes it actually makes sense to think about having more than one call. So let me tell you a story about one of the customers that I've worked closely with. They work in human trafficking. They work against human trafficking. So they build applications to help security personnel, police departments, et cetera, hunt down and catch people who are working in human trafficking, and they work to free people who are trapped in those environments. And they do this through a mobile application. Now, what they have this mobile application that an undercover agent will wear or will activate when they are in conversation with a criminal. And when they activate that notification, they connect the application to a hub, a conference, in this case, a Twilio conference, that is constantly recorded. And so they may set the mobile phone on the desk, for example, and it's picking up the audio in the room, and they have a conversation with the criminal. All the content of the conversation is being picked up and captured in this recorded call. Now, these are often very dangerous environments for these investigators. They can, as you can imagine, plenty of things can go wrong here. So they recently added a feature they wanted to add a feature to keep the agent more secure. And so they often have a team of people backing up the agent. They have someone at headquarters maybe connected on a web browser, maybe other agents in the field who are on a mobile phone. And they needed a quick way for the investigator in the field to be able to communicate if they were in trouble. So what they did was they created a second hub, a side channel conversation that is constantly connected, concurrent with the recorded call. So there are two calls going on in our traditional sense. There are two calls active at any point in time, two hubs. One, the recorded call that pristinely captures the audio between the criminal and the investigator, or the potential criminal and the investigator, so it can be submitted for evidence in a trial, et cetera. And then they have this side channel. Now, what's interesting about this is the user of the security app, they actually can't hear what's going on in the side channel, but their audio is piped into the side channel. This is all using our Twilio client SDK, or our programmable voice SDK. And that audio is piped into the side channel, and if they're in trouble, they've agreed with this team of personnel off-site on a safe word, something they can say if they need help. And they shout the safe word, they say what they need to say, and these agents swoop in and help in a dangerous situation. So this is one example. I've seen similar examples in call center when you want to have a manager coaching an agent in real time. So you set up a side channel conversation between the manager and the agent, and in parallel you have the call between the agent and a consumer. So don't be afraid to do this. Don't be afraid to have one user engaged in multiple calls simultaneously. Okay, next point. Think carefully about session discovery and notifications. So how do users in your application discover a call? How are they notified when they're being called? How do they get connected to a call? So I've shown this diagram a few times. You know, the old method for SIP was to send an invitation, and that invitation would cause your phone to ring. And you had a limited amount of time to respond to that invitation, send back this 200 OK message. And if you didn't do that, then you missed the call. That was it. I would argue that this today is application logic. This is logic that shouldn't belong in our protocol. This belongs in our application. Because think about the variety of device types and the variety of networks that our users are on. Users who are connected to a web application probably need to receive a notification over a web socket. Users who are connected using a mobile application probably need to receive a push. Users who are on the PSTN need to receive this kind of invitation. They actually need their phone to ring, perhaps. So as you're making choices in building your application, think carefully about how you build notifications. Let me give you an example from a telemedicine use case. So in a telemedicine, the example I'll talk about is one of our customers actually here in Europe. They're in Germany, and they have the following actors. They have an agent application. This is the doctor, in this case, who is sitting in an office at a web browser using our Twilio client SDK to make voice calls. So they're using Google Chrome or Firefox to make voice calls in the browser. Then we have a consumer application out in the field. This is a mobile app used for these telemedicine calls. Next, we have the actual call. This is the hub that I talked about earlier. And we have the application server in the back end. So here's how they set up a session. And you can see that when I walk through this, pay attention to how the notifications differ based on the different type of user involved. So when it's time for an appointment, first of all, they send a synchronous notification over a WebSocket to the agent's application. You could use our sync API to do something like this. So that the doctor actually sees a pop-up, hey, your appointment with John, it's time for your appointment with John. Click here when you're ready to begin the session. So make sure they get the doctor on the line first. When the doctor clicks that notification, they create the call, and they name the call using an appointment ID. So this is, again, using our conference primitive. They are creating a conference with an appointment ID. After they after they receive a notification that the conference has been created, they then send a push notification to the consumer, but this time they're using VoIP push. And you can do this using our Notify product. So they send, if you're not familiar with VoIP push, it's a little bit different than your traditional push notification. VoIP push, this is Apple's term for it, but you can do similar things with Google Cloud Messenger or Firebase Cloud Messenger. VoIP push is a guaranteed delivery, very low latency push notification that does not display to the user. It wakes up your app in the background, gives you a few minutes to run your own code, and then you can actually surface the notification to the user in whatever way you like. So if you're building an iOS application, make sure you take a look at VoIP pushes. So they send a VoIP push out to the consumer application, the patient application, and that wakes up the app. The app starts to get ready to connect to the call, and the consumer sees a notification on their screen that says something like, the doctor is ready to see you now. Once the user responds to that notification, they then connect to the call. The doctor is already standing by, and they begin the telemedicine appointment. You can see why separating the notification mechanism from the actual call itself is an important consideration here. So just some questions to consider as you think through your own applications. These are ones that I often ask customers when I'm helping them design their applications. What will the user environment be for the primary users of your application? Will they be sitting in an office? Will they be on a mobile device? Will they be multi-device users? Will they be shifting between devices? What's the order of operations for setting up a call in your application? Don't assume that you have to have one user call another. Think about what back-end process should trigger a call. Who's the right person to be on the call first? Is it better to have the consumer on the call first or the agent on the call first, et cetera? Should notifications be synchronous or asynchronous? And should they have an expiry time? How long should the session notifications live? Can users reconnect? And if so, how? How does the application know how to reconnect them? These are all things to consider. And the last one that I'm starting to see show up in some of our customers' applications is what do you do when the application has been in the background for a long period of time, even though the user is still engaged in a conversation? If you're building a VoIP application and the user is engaged in a call and they move the app to the background, do you want to maybe, after 5 minutes of inactivity, send them a notification to try to bring them back to the app, bring the app back to the foreground? You often see this in chat applications as well, but I'm starting to see it pop up in synchronous calls too. Okay, final point, synchronized state across endpoints. We talked about this in our sync demo today. Probably the best way to explain why this is important is a really common use case we see, and it starts when you give people more than one device. When Alice wants to call Bob, Alice is on the phone with Bob, but she needs to leave the house. She needs to run to the grocery store. Well, it would be great if she could join that call from her phone. So she connects if you've synchronized state across endpoints, if her mobile phone knows the name of this conference, the name of this room, then the mobile phone can connect to the room and you can tear down the original call. This is also great when Alice loses connection. If you know the name of the conference in that application, then when the connection drops as she goes through a tunnel, she can just reconnect on the other side. Or the application can do it for her because the application sees that the call has dropped. You get the idea. This is an example of what I've started to see. This is one of our, this is kind of a hard to understand example, but one of our customers who's built a great voice conferencing application that you run on the desktop shows you this. Now, it doesn't quite get the whole message across here, but when I start a call, whether from any of their applications, from the web app, from the mobile app, from the iOS app, the Android app, all of the applications get this state. They know that a call is in progress. And there's another icon in the UI that I can click to hand the call off from one of the apps to another. So that's it. Quick overview of building better conversations with some new call models. If you see great calling experiences, I'd love to hear about them. So send them to me at this email address. And that's it. Thanks for your time today.